Okay, so welcome back, and today we're going to start logarithmic functions. So what is a logarithmic function? Well, first of all, there are lots of applications to logarithmic functions. So there, for example, the Richter scale for measuring the severity of an earthquake is based on a logarithmic scale. What else? pH scale is logarithmic. Oh, a decibel scale, right? Measuring the soundness, the relative soundness, the relative loudness of a sound. Okay, so those are all based on logarithmic scales. Okay, so what is a logarithm? Well, the definition of a logarithm is an exponent. That's really what it is. It's an exponent. So the logarithm with a certain base b of a number. So the log of a certain number is the exponent that the base must be raised to in order to get that number. So in other words, it's an exponent. So a logarithm is an exponent. So, and this is how we write it, okay? So this is log base b, or logarithm of base b of x. So a logarithm with a base of b of x is equal to y. So it means y is an exponent. So in other words, this is the exponent that we have to raise b to in order to get x. Okay? And so we would say the logarithm, or the base b logarithm of x is equal to y. Okay? Or we could say plainly log base b of x is y. Okay? Now, or you could say b raised to the power of y is equal to x. We could say it that way too. And that brings up a point of writing logarithmic functions in exponential form, because logarithms are the inverse function of exponential functions. Remember, exponential functions are one-to-one, which means that they have an inverse. Well, guess what? The inverse function of an exponential is a logarithmic function. So how would we rewrite this in exponential form? Well, we could take any log and write it in exponential form by taking b to the y is equal to x. So we take b raised to the power of y is equal to x. Okay? And so that's how you write a logarithmic function in exponential form. Okay? And what else? Okay, so I'm thinking, what you're thinking when you're looking at these is you're saying, hey, what exponent do I need to raise b to in order to equal x? So for example, if I give you the base 2 logarithm of 32 is 5. Okay, so if I say the base 2 logarithm of 32 is 5. What does this mean? Well, it means what? It means that if I raise 2 to the 5th power, that's going to equal 32, and it does. So if I didn't have that, right? If I didn't have that, and I said, okay, I want to know what's log base 2 of 32. Well, I got to think to myself, okay, what exponent, right? What exponent do I need to raise 2 to get 32, right? So this is y. So if I wanted to solve for y in this case, I would have to think, okay, 2 raised to what power is equal to 32. And then we can solve that. Okay, we'll get to that a little later. Okay, but the answer is 5. Okay, the answer is 5. So, okay. Now, for the definition of a logarithm, base b of a positive number, x, it satisfies the following definition. X is greater than 0, b is greater than 0, and also b can't be equal to 1, right? Because we won't have a logarithmic function at that point. So b can't equal 1, okay? And if you look at this, b can't equal 1 because, again, we don't have an exponential, right? Remember, the base can't be equal to 1 for both logarithms and exponential functions, okay? Now, also, since the logarithmic functions and exponential functions are inverse operations of each other, the base and the range change. So obviously here, if we look at this exponential of x and y, right? So here x and y are switched, okay? Because we're changing the logarithmic function into an exponential expression, okay? So in this case here, because this is an inverse operation, inverse function of exponentials, we know that, okay, so if we take the basic exponential function, think of it this way. If we take the basic exponential function, we know from our previous videos, we know what the domain and the range is for that function. Okay, so if we take f of x equal to b to the x, we know what the domain and the range of this function is. The domain is all real numbers. The range is all positive y values, so from 0 to a positive infinity. But if we look at the log, the domain and the range is opposite. So here, the domain of the log function, log base b of x equal to y, this range is all real numbers, but the domain is all positive real numbers, so from 0 to positive infinity. Okay? And this, instead of having a horizontal asymptote like for the exponential function, it has a vertical asymptote at x equals 0. Okay? Okay, we'll stop there and we'll do some examples next time.